So here we are. This is section 2.7. We're talking about greater than, less than. Now, again, we did this in the review. That's what's nice. We did that review for 3 or 4 weeks. I think 4 weeks. And so we saw a lot of these things, which will be nice for you. So we talked about greater than, less than, and we talked about writing interval notation. So this will be a nice second look at it. Hopefully you'll be really comfortable with it. A lot of the stuff on this exam is stuff you have seen before in our review. That's why part of why we did the review. Anyway, so this says x greater than or equal to 3. It's kind of small. Make it bigger there. X greater than or equal to 3. And they want us to put that on the number line. See how they have that little number line there? So how would that look on the number line? You probably can't see it. I'm just going to draw a new number line right here. So basically, we're just going to go to 3. And we're going to shade. Now, is this one going to use a parenthesis or a bracket? Yeah, you remember? How do you know? What's the rule there? The bar is the bracket. Yeah, I tried to give you that BB thing. The bar is the bracket. Yeah. So this one's got the equals bar, right? Greater than or equal, so that's going to be bracket. And the shading is to the right. How did I know it was to the right? Because X is greater, and greater stuff is always right? The greater numbers like 4, 5, 6, etc. are to the right, aren't they? So you're always shading where the X is. The X is to the right. The greater stuff is to the right. So there's how you would shade it on the number line. And then finally, and I'm going to go on the system actually and show you exactly how to do that with their little tools. But first, let's do interval notation. Remember interval notation? That's left edge, comma, right edge with like parentheses and brackets and things. So, and they mean the left edge and the right edge of the chunk of shading. So here's the chunk of shading. What's the left edge of that chunk of shading? 3. So that's part will be 3 with the bracket. And what's the right edge? Yeah, it goes forever to the right. That's what that arrow means, huh? It's everything greater than 3, which is forever to the right. And so that's the infinity. Now, they specifically say how to enter infinity. So for this program, this thing we're doing, it's called My Open Math, the program we're using. It's a free resource, My Open Math. It's double, not zeros, but double letter O. They want to use letters so as not to confuse it with numbers. So you go O, and then you got to put a parenthesis. Why do we put a parenthesis? Yeah, you never right on infinity. Remember, the bracket has a straight edge, means you're straight on the number. You can never be right on infinity, huh? So remember, those are 2-letter O's. I got confused when I first used it. And I was putting in 2 number zeros, and it kept telling me no. And I was like, what? I'm right. But then I read the fine print, and it said, oh, letters. Okay. Yeah. So make sure you know that's 2-letter O's. Okay. So yeah, so one more thing on the number line. They're going to actually have you, instead of a bracket, they're going to have you do a solid dot and then shading to the right. So a solid dot is the same as a bracket. So bracket equals solid dot. Parentheses equal open dot. Because why? Because a parenthesis means you're just around the number. You're close to it. You're not right on it, right? So it's like a hole drilled out. They just drilled out the hole. You don't quite touch that. Whereas we do touch the 3, right? We are a solid dot because we're greater than or equal to 3. We can be right on the 3 or bigger. So we're smack on there. All right, so I'm going to move on. I think number 2's cake for you. Let's move on to something harder. Number 3. 7 minus 7x minus 1 less than or equal to minus 8. So can you solve that equation for x? And then they want you to put it on the number line and write interval notation. Let me give you a second. I think you know this stuff. Let me jump in. So add 1 to both sides. These cancel. Get to there. And then divide by -7. But again, when you divide by a negative number, right then you have to flip the symbol the other way. When divide by a negative, flip the symbol. Right there. So we flip it the other way. Whenever you divide by a negative, you got to flip that symbol the other way. And then these cancel, so we get x greater than or equal to. And what is negative 7 divided by negative 7? That's just positive 1, because 2 negatives make positive. 7 divided by 7 is 1. So, okay, now can you put that answer on a number line and make an interval notation? I'll give you a second. All right, so on the number line, we're going to go solid dot. Right, why is it a solid dot? Be right on the one. Yes, solid bar, solid dot. How about that? I'm making up another comparison. So if you have a solid bar, then you're going to have a solid dot because you're right on the one. You're greater than or equal to the one. You can be right on the one. Am I going to shade to the right or to the left of the one? The x is greater. Where's the greater stuff? To the right. Right? The x is to the right, isn't it? Greater stuff is to the right, right? The x is on the wide side of the symbol, greater. All right, and then we need to write that as an interval. So that's going to be bracket 1, comma, infinity. I'm just going to make a normal infinity there. And we always put a parenthesis by infinity. There we go. Is that good? Questions on that one? All is well? How about we do, in fact, yeah, let's do number 6. I'll bring it right up here for us. So 3 times 15x minus 9 greater than 11 plus 9x. And so we take that 3 and we distribute. And that's 45x minus 27. We good to there so far? And now we have x's on opposite sides. So what do we do when we have x's on opposite sides? Yeah, get them to one side, huh? Get rid of them on one side. Yeah, so I usually get rid of the lower one, subtract 9x. And then that cancels out. You can use your calculator there. What is that going to be? 36? X minus 27 greater than 11. Now we're still working to get x alone. What's our next step to get x alone? The 27, add the 20. Always do the opposite, huh? We're always doing the opposite to get rid of things. So we get 36x, what's that, 38? And last step, divide. There we go. So we got x greater. Oh, was I supposed to turn the symbol there? No, because I didn't divide by a negative. I just divided by a regular 36. Only when you divide by negative, huh? Yeah, and then what do we have to do with that 38 over 36? Reduce it, huh? Yeah, divide by 2. A lot of your calculators will do that automatically. 19/18. And now all they want is interval notation answer. So it's greater. So how are we going to make that as an interval notation? If you want to go to the number line, it can help you. You don't have to, though. I'm just going to say greater than. So greater is going to be 19/18 to infinity. Parentheses on both, huh? No brackets there because there's no bars. Right? It's just from 19/18 to infinity because it's greater, so it goes up to positive infinity. Good on that? Making sense? How about we move to number 9 here? Let's try this one. Now we've got decimals. Decimals, just use a calculator is my main advice. 0.4x plus 13 greater than 9.1 plus 0.6x. So yeah, just do all the same stuff you did before, but just use a calculator. Some people like to multiply through by 10 or 100 to get rid of decimals. You totally can do that if you want to. I think it's just as easy just to use your calculator. So either way is totally fine though. So we got x's on both sides, so what do we got to do? What do you got to do when you got x's on both sides? Get rid of those. Really, it's either one. But yeah, I usually do the lower one. So I'll subtract 0.4x from both sides. But you could subtract 0.6x if you want. That'll work too. It doesn't really matter. So, and this will be what? 0.2x. And then x is saying, I want to be alone. So what's next? Yeah, get rid of the 9.1, huh? Yeah, because that's what's with x. Right, we always get rid of whatever's with x. That's going to be, is it 3.9?
Yeah.
All right. And now, last step to get x alone? Divide. It's almost always divide, huh? Usually what we have left at the end. And so, is it 150? Is it 195?
Yes.
Or 19.5? Is that right? 19.5, right?
Yeah.
So just use your calculator, just divide, and you get 19.5. And now, it's kind of weird to have the x on the right side. I would suggest that you just flip the whole thing around. It'll be easier for you to read. So when you flip it, everything flips, including the symbol, huh? To keep the same meaning. So when you flip it, it's going to go like that, and that's probably easier for you to read. Is that good? That's saying the same thing, isn't it? See how the x is on the narrow side of the symbol, and he's still on the narrow side? Nothing's really changed. So the x is less than 19.5, isn't it? So how do we say that as an interval? Where lesser things go down to negative infinity, don't they? So it's going to go from negative infinity up to 19.5, parentheses, because there's no solid bar, no brackets. So there's the interval notation. That's what they want in the end, is the interval notation answer. Questions on that one? Yeah, so if you were to graph this thing on a number line, and I'll just stick 19.5 right in the middle. Okay, now what does that say again? X is less, huh? It's on the narrow side, x is less. So if I'm going to put x, is it going to be over on the right, or is it going to be over on the left? Where are the lesser things? Left, huh? Going to be on the left side. So it's over here. Well, that means that's where the shading goes. So it's like this. So, and then when you do interval notation, remember it's left edge, right edge. So what is the left edge of that shading? Negative infinity, huh? Because it goes left forever. So left forever. Those are negative numbers way back there, aren't there? So negative infinity. To the right is positive infinity. So negative infinity up to 19.5. That's the section. That's the interval. Good, okay. So 10 is kind of the same. 11, they're giving me an or statement there. We could do 10. Okay, yeah, let me do 10. Let me get a little fresh room for 10 for us. Right here where we can see it better. So number 10, I've got it on my other screen so I can do that. So 4 less than or equal negative 5x minus 1 less than 9. Like that. Okay. So same kind of thing. They want us to solve for x and then put it on the number line and do the interval notation. So it's a three-parter. We call that a compound inequality. You know the deal. Just get x alone again. So all right. So this is a three-parter, huh? And we're looking there, and right in here is where we focus. Don't worry about the 4 and the 9. Just focus right in there. And x is a little world, and x is saying, I want to be alone. Get rid of this negative 1 that's next to me and get rid of this negative 5. So we start with the negative 1 and we add 1 to all three. And we get 5. And this is minus 5x. And this is 10. Good so far? And now what do we do to get x alone? Divide by negative. Now I'm dividing by a negative. So what needs to happen? Both signs flip. Right there, right then. Both signs flip around, don't they? That one, and that one has the bar. That one, right? When you divide by a negative. Okay. And so then what does that give us? This is negative 1. These cancel. X is alone. And this is 10 over negative 5. Negative 2, right? Positive divided by negative is negative. And 5 goes into 10 2 times. Good so far? Now, that's a hard way. It's telling you the truth, and I'll show you how to read it, but let me just say this. It'll be way easier for you to read it if you flip it around. We don't like all the signs going that other way, so I would grab Here's what's telling me also. Which one of these is a lower number? -1 or -2? Which is, remember the number line? It helps if I do the number line. Let me go to the number line for you. If you go on the number line, like here's 0, here's -1, here's -2. So who's really a lower number? -2. See how they're saying it backwards? They have the lower one over here and the higher one here. Now, it's still telling the truth, and I'll show you how it's really saying the truth in a minute, but I'm saying it'll be way easier if you just flip the whole thing around. You don't want the lower one on the right. That's just an awkward way to read a inequality statement. So just flip the entire thing. When the lower one's on the right, we don't want it that. We want the lower on the left. So just flip the whole thing around. So put the -2 here, the -1 here, and both symbols flip. So this guy goes this way and this guy goes this way. See how I haven't changed any meaning, right? Look at the x with the -2. He's on the wide side of the -2, bigger than the -2. He's still on the wide side of the -2. Nothing's changed. See how the x is on the narrow side compared to the -1? See how the x is on the narrow side compared to the -1? He still has the bar with the -1. Say, nothing's changed, right? It's saying the same thing it was saying before. It's just easier for us to read it this way. Now we've got the lower number on the left and the higher number on the right. So we can look at it and go, oh, it's just saying all the numbers between -2 and -1, huh? And I put an open dot here and a solid dot there, right? Solid bar, solid, oh, not at 0. What am I doing? Yeah, I just got obsessed with the dot. Yeah, solid bar, solid dot there at -1, right? Okay, and then the shading, the x is in between them, isn't it? So the x, the shading, is in between -2 and -1, and then the way you would say it as an interval, you'd go parenthesis -2 to -1 bracket, right? Because again, the solid bar at the -1 is a solid bracket. Like that. Does that make sense there? On number 11, they give us a statement like this. -8x minus 1 is greater than -25, or -9x plus 1 is less than or equal to -35. So on this one, they want us to basically just solve both of those, and when we're done, we'll do an interval with a u in the middle. I'll show you. So it's basically, let's just solve two equations. So let's solve this one, add the 1. So they're just two totally separate inequality statements. And what do we get here? -24. And last step, divide by -8. I'm dividing by a negative. So what do I need to do? Flip that symbol, huh? Flip that symbol around so these cancel. And so we get x less than, and what is -24 over -8? +3, huh? +3. Okay, now on the other side, let's come over here. Let's subtract 1 from both sides. Get -9x less than or equal to -36. Divide by -9. And, oh, I just divided by a negative, didn't I? So right there, almost forgot. Got to turn that symbol around. And what do I get here? This is going to be +4, right? Because it's two negatives. -36 over -9, +4. Okay. And then they want me to keep that or in between. Now it's time to write the intervals. So how do I write this interval? Yeah, less than 3 means it's going to go down to -infinity, huh? Exactly. So -infinity to 3, parenthesis. No brackets there, huh? And the or is a u. It just means unite. The u stands for, when we use the u in math, it means unite, meaning this interval and that interval united into one answer. It's this or it's that, either one united. Then how do you say this? Greater than or equal to 4? Is that going to go to positive infinity or negative infinity? Because it's greater, huh? Yeah. So and is it a bracket or a parenthesis? bracket it 4 to infinity. And infinity always gets a parenthesis because you're never right on infinity. There we go. That's all we're doing. Yeah, Isabella. Remember these? Remember absolute value greater than, less than? Remember how we do that? Let me give you the instructions for how you do absolute value greater than, less than. All right. So how do you do absolute value inside? Let me just write up here. How do you do absolute value with a lesser kind of equation, or less than or equal to, either one? Step 1 is to get the absolute value alone, and then step 2 is, for the less, is to go negative number, and then inside, and then positive number. So I'll write remove absolute values, and you write a statement like that, and then you solve, and step 3, your answer is going to be like number, comma, number, like that. So that's the format for absolute value less than. And then for greater than, it makes 2 of them. We'll do one of those in a second. But let's start with the absolute value less than. So let's give that a try on this question. So my first step is to get the absolute value alone. It really, what we mean is if there was like a 7 out here or something like that, I would subtract 7, But anyway, we don't have anything like that. So step 1 is really done. It's already, the absolute value is already all there is on the left side. He's alone on the left side. So on to step 2 we go. Remove the absolute values. Tear them off. Get rid of them. And what do you write when you get rid of them? Well, you take the 2 and you put it on the left as a negative 2. Put the x minus 8 in the center, no more absolute values, and the positive 2 on the right. See the negative number on the left and the positive on the right? And notice both symbols are less, aren't they? See how they're both saying less on that? So they're both saying less. And what that represents is the fact that it's this is like the smallest, the medium, and the large, right? If you're ordering a soda at a restaurant, right? Isn't that a true relationship there? The smallest is smaller than the medium, and the medium is smaller than the large. That's basically what we're saying in these triple statements. Smallest, medium, large. Smallest is smaller than the medium is smaller than the large. See how minus 2 is the smallest number, positive 2 is the biggest, and we're saying this x thing is between them, it's medium. That's why we're putting them both that way. That's what the statement is really saying. Okay, so anyway, now we solve it. X is saying I want to be alone, so add the 8, right? Add the 8 to all 3. And we get x. This is 10, and this is 6. And then our answer is bracket 610, just like that. Remember that? Is it all coming back? Seem easy? Now on that. All right, so let's see it. So what do? Well, you remove the absolute values, and you put a negative 3 over here, a positive 3 over here, and you put the 4x minus 8 in the middle, and both symbols are less than, aren't they? Both symbols are less than. We good? So that's how we handle absolute value less. It's going to be a little different for greater. You remember probably, and we'll see it in a second. All right, so x is yelling out, I want to be alone. There's the 3-parter. So we add the 8 to all 3. These cancel. So 4x, we get 11, we get 5. And last step to get x alone is usually divide. No difference here. And so we get x, there's 11 fourths, there's 5 fourths, and then they want us to write that as an interval. Well, that's real easy, actually. It's just 5 fourths, comma, 11 fourths, with parentheses. No brackets, right? No bars there, so no brackets, and we're done. Not too bad. Shall we move on to the greater? Let's try the greater, so if you're good with that. For greater, absolute value greater, what do? Step one, again, is to get the absolute value alone. We haven't had to do that yet. We will in a minute. Get the absolute value alone first off. So before you do any removal, get it alone. Step two is remove the absolute values. We've been starting on step two so far, the problems we've done, because, yeah, we just remove the absolute values. So when you remove them, for greater, it's going to end up, you're going to have the inside, oops, one more room here. You're going to have the inside less than or equal to the negative number, or the inside greater than or equal to the positive number. And then you're going to go on and solve this, and go on and solve this, and you'll end up getting negative infinity number united with number to infinity. That'll be the form of the answer. So you have the two brackets. Remember, greater has a greater number, has two brackets, or two sets like that, whereas the less, the absolute value less, that only had one. If we look back, there's only just one interval for absolute value less. All right. Okay, so let's dive on down. So we have the absolute value there. So it's greater, so we're gonna remove the absolute value signs. And what do we always do? We're gonna make two separate statements, right? So the 3x plus 9 less than or equal to the negative 6, or the 3x plus 9 greater than or equal to the positive 6. So again, we do the negative and the positive. See how we take that 6 and we do the negative and the positive, but we do it in two separate statements instead of one big triple compound statement, right? And then we just solve them both again. So we say, all right, here we go, going to solve it. Subtract 9 from both. And we get 3x less than or equal to minus 15. Same thing over here. Subtract 9. And we get 3x greater than or equal to minus 3. Last step to get x alone, divide by 3. Divide by 3. And so we get x. Do I need to turn the symbol? And no, we don't turn the symbol because we divided by a positive 3, not a negative, huh? It's only when you divide by a negative. Just leave it as it is. Leave them both as they are. Even though the answers came out negative, that doesn't matter. It matters what we divided by, what we put under the bar. We put a regular 3 under the bar, so no turning the symbol, right? All right, so there we go. So now this one is less, so it goes down to negative infinity. That's why this one has the negative infinity. Negative 5. Put the u in the middle. Remember, the or leads to the u. Bracket negative 1 to positive infinity, because this one's greater, so it goes up to positive infinity. There's our interval notation answer. It'll always look like that for the absolute value greater. You have the two intervals, and they'll always have the negative infinity on the left, positive infinity on the right. Seem good? Yeah, so first step is to get the absolute values alone. Get them alone. So that means I got to get rid of that 3. So I don't remove them yet. First get them alone. And so I get 2 absolute value x minus 1 greater than 1. And then what do I do to finish getting absolute value alone? Divide by that 2. Boom. And that's absolute value x minus 1 greater than a half, like that. So is that good to? So that was all step 1, right? I had to first get the absolute values alone. Now go into step 2, where you remove the absolute values, right? So that means I'm going to remove this, and I'm going to write the two statements, right? So x minus 1 less than. It's always less than the negative. Have you noticed the pattern? It's always less than the negative or greater than the positive. Everybody see that? right? So whenever for the absolute value greater, it's less than the negative or greater than the positive. The symbols go opposite ways, don't they? All right, let's do it. So yeah, I would just use decimals. I like that idea. I like that. Let's just make that. So I'm just going to add 1 to both sides here. That's gone. And we get x less than, yeah. And I would just do this on your calculator, just minus half plus 1. It'll come out plus 0.5, huh? On your calculator? Question? We can do the same thing. Add the 1. And that's gone. Again, you can just use your calculator. It'll give you a decimal. This will be what, 1.5? 1 plus a half, 1.5, 1.5. Yeah, let's just do decimals. I think it'll take decimals. Every now and then it'll want fractions, and so you'll have to redo it because it'll tell you no. So, all right, so how do we put in the interval less than, there's going to be 2 separate intervals, right? With an or in between, which means a u in between. So how do you do x less than 0.5? Is that go to positive infinity or negative infinity? Lesser stuff goes down to negative infinity, huh? So that's going to be... It's going to be negative infinity, always a parenthesis, and 0.5 parenthesis united with, and then this one will be 1.5 to infinity, because it goes up to infinity. All right.